Assalamu alaikum warahmatullahi wabarakatuh. Our lesson today we are talking about algebraic fractional function. Algebraic fractional function. We learn if we have f of x if the function equal x minus 1. We know what does it mean, the zeros of the function. Zeros function denoted by z of f. And it's mean the value of x which make the value of the function equal 0. So if we say x minus 1 equals 0, then we can write x equal 1. X equal 1, it's mean if we substitution by x equal 1 here, we find the value 1 minus 1 equals 0, so the zeros of the function equal 1. It's mean if we substitution by x equal 1, the function equals 0. And we write z of f equal the set of 1. Now we are talking about algebraic fractional function. If we have the function n of x equal the function in the numerator and another function on the denominator, x plus 3 over x minus 1. Now we are talking about algebraic fractional function. We must know what does it mean, domain. The domain, it's mean the values of x which make the function is defined or has a value. For example, if we say n of 1, n of zeros, it's mean 0 plus 3 over 0 minus 1. It's equal negative 3. It is a value. So we can substitution by x equals 0. And if we say n of 1 equal 1 plus 3 over 1 minus 1, it will be 4 over 0. Oh, 4 over 0. Undefined. So we can't substitution by x equal 1 or x equal not equal 1. Now the domain, any number in R except 1. Domain, it's mean the values of x which make n of x has a value. N of x has a value when x equal n number in R except 1. So we can write the domain equal R except the set of 1. Now what does it mean, the domain? The domain equal R except the set of zeros of denominators. We like add the denominators. If we wanted to find the domain, we look at the denominator. For example, find the domain of the following function. Number 1, f x equal x plus 3 over x minus 4. We look at the denominator, x minus 4. We find the zeros of the denominator. We write the number with x but by different sign. If x equal 4, if we substitution by x equal 4, then the denominator 4 minus 4 equals 0. Keep a number 7 over 0 undefined. So we can write the domain equal R except 4. Why 4? Because 4 اللي هو z of denominator equal 4. We don't write this, we only write this. Number 2, if we have f of x equal x power 2 minus 9 over x power 2 plus 4x plus 3. Number 1, we factorize numerator and denominator. Factorize the first x power 2 minus 9 is a difference between two squares. we open two brackets x and x, and we find the root of 9. Root of 9, 3. Both 3 positive and negative. Denominator, we put two brackets x and x. We find the two numbers its product equal 3. هو only 1 times 3. And the sign of 3 is positive. So we want two numbers its product equal 3 and their sum equal 4. Only 1 times 3. 1 times 3 equal 3. And 1 plus 3 equal 4. We write 3 and 1. If the last number positive, we drop the middle sign as it is. Positive and positive. So we can write the domain equal R except negative 3 and negative 1. Number 3, if we have fx equal x power 2 minus 3x minus 10 over x power 2 plus 9x plus 20. First, we factorize numerator and denominator. X and x. We want two numbers. Its product equal 10. Two numbers, its product equal 10. We have 1 times 10 equal 10. And 2 times 5 equal 10. Look at the sign. It's negative. It's negative, it means subtract. If we subtract the two numbers, the result equals 3. 10 minus 1, 9. 5 minus 2, 3. So the two numbers, its product equal 10, and the difference between them 3 is 5 and 2. We write 5 and 2. If the last number is a negative, we write one positive and the other negative, but the greater takes the middle sign. Greater here 5. 5 take the negative because negative is the sign of the middle, and the 2 takes positive. The last one, x power 2 plus 9x plus 20. We put two brackets, we write x and x. We want two numbers. Its product equal 20 and their sum equal 9. 20 and their sum equal 9. We have 1 times 20. What else? Excellent. 2 times 10. And what else? 3, not 3. 4. Excellent. 4 times 5. The two numbers product equal 20 and their sum equal 9. It's 4 and 5. We write 4 and 5. We drop the middle sign in the two brackets. We write positive and positive. So we can write the domain equal R except we write the same number with an x but by different sign. X except negative 4 and negative 5. It's mean here x doesn't equal negative 4 and x doesn't equal negative 5. Another example. If we have x, end of x equal x power 2 3x minus 18 over x power 2 plus 3x. Substitution the numerator. That's excellent. X and x. We find two numbers that equal 3 or 18. Excellent, 18. We want two numbers that equal 18, and the difference in them is 3. We have 1 times 18. What else? 2 times 9 and 3 times 6. Excellent. Why 3 times 6? Because the difference between 6 and 3 is 3. We write 3 and 6. The number takes the middle sign because 18 is a negative. If 18 negative, we write positive and the negative. The greater number takes the middle sign. 6 is negative and the 3 is a positive. X power 2 plus 3x. Who can solve? X power 2 plus 3x. It's binomials, two terms. But if we look this expression, x power 2 plus 3x. x repeated. So we can take x as the common factor. If we take x as the common factor, here x power 2. X power 2. We take x power 2. We take x with x. Minus 3x. We take x 3. The domain equal r, except from this bracket we can take negative 3, but here x, or not 1, x here not 1. We take the number plus or minus x. We hasn't any number plus or minus, so we take zeros. We take the 0. Then the domain equal r except negative 3 and 0. Why 0? Because with substitution in the denominator as x equals 0, the denominator equal 0 undefined. Now we take, what does it mean the common domain? Common domain, we have many factors, many functions. Many function, we factorize each function, so we write the domain. For example, as we say, find the common domain from the following. Number 1, n1 of x equal x plus 3 over x minus 2, and n2 of x minus 1 over x power 2 minus 4. The first, we doesn't need to factorize, and the second, n2, we factorize the denominator, difference between two squares, we open two brackets, x and x, and we write 2 positive and 2 negative. So the domain equal r except x, and from this we take 2, negative 2. From this we take 2, but we write 2 before, doesn't repeat it. We doesn't repeat it. So the common domain r except 2 and negative 2. Another example. If we have n1 of x equal x plus 1 over x times x minus 2, n2 of x plus 3 over x plus minus 4, x minus 2. So write the common domain we can write r except from this 2. What else? Oh, 0. Don't forget zeros. 0 because x we take 0. 4 we write 2 before, doesn't repeat it. Evaluation. Find the domain from the following. Number 1, n of x power 2 plus 2x minus 15 over x power 2 plus 4x minus 21. Number 2, n of x power 2 minus 9 over x power 2 plus 3x. Thank you.